Come here. Go to the front. We are starting at 0, 0. Go 10 steps that way. Go all the way to the wall. Turn left. Walk that way. I am.
That's why the jokes came up, because he thought you would catch it.
You can stop. You don't need to leave now. Now, what he's done here is that he went east and then north, and I'm finding, how far is this? You got some nerves, weren't you? But you didn't flinch. That was impressive. That's trust, gentlemen. That's trust. Way to go. We need to know how far that is. What do you do? That's all it is. What's that? Pretty much. Whatever you're looking at here. So when I go back to a problem like this, I want you to sit there. I want you to sit there and look at it when they're talking about distance of a pass. You're not worrying about the arc and all that kind of junk yet. We'll worry about that later on when we start talking about those things. Yes, sir?
So it's okay if you don't get a hold of them?
Correct. You're not going to. Not everything lands on 1 or 2. You're going to have rounding stuff. So you start to think about the idea of, if you're starting at one point and you're passing it to another point, how far is that distance going across? It's Pythagorean theorem is all this is. You guys know that the Pythagorean theorem is just the distance formula without the x's and x of 1s and x of 2s, right? That's all it is. The change in x is how far apart they are. What's that side line? Change in y, how far apart are those endpoints? And there's your diagonal. That's all it is. So if I'm looking at something here, you want to figure out how far this pass winds up being, I can just look at the diagram without having to read all of it, because if you get lost, I know you guys. I know you guys get lost in word problems. Remember linear programming?
Yeah, that's not too far.
Love that stuff. X amount of dollars for this, and then maximize that. The rest, the next. Those were fun. All you're doing here, if you're looking at this, is you're just creating this. Distance is measured via a right angle. Shortest distance between 2 points is always a straight line. That straight line you can find by using Pythagorean theorem. If I'm looking at those two, oh, I'm sorry, x's. Between 20 to 40 is how far? Woo. Between 5 and 28 is how far? 23. Pythagorean theorem for the other side. That's it. You're looking at it in terms of something easier. Use Pythagorean theorem. It's the distance formula, by all means. If you want to write it out in terms of x sub 1s, y sub 1s, x sub 2s, y sub 2s, there's nothing wrong with that. I find it's easier to realize that I'm looking at distance formula and map it and go. It's quicker. Does that make sense? Also, in this secondary part, we talk a lot about some of the old geometry formulas. And these are some of the basic ones you probably remember. Area of a rectangle, perimeter of a rectangle, area of a circle, circumference of the circle, area of a triangle, the perimeter of a triangle. Find the volume of a cylinder. That's not a cylinder, it's a, not a cube, a, no, rectangular prism, thank you. I forgot what that was called. The cylinder and then the sphere. Those were all formulas you guys used a ton of last year in geometry. They should not be that difficult to work with. Because what we're going to do today is that we're going to look at the cylinder has a volume of 200 cubic centimeters, a radius of 4. What's the height? So you're going to solve for the parts of the actual formula. So if I'm looking at the volume of a cylinder, was pi r squared times the height, all I have to do is substitute in Now, this is where you have to be careful. You have 200 was it 4 squared pi times the height. 4 squared is easy, it's what? 16. So in my calculator, to get the height by itself, I have to what? Am I subtracting? I gotta divide by 16 pi, but what do you have to make sure you use for the denominator? You gotta make sure you have parentheses around it or find the fraction bar. I honestly not quite sure where the fraction bar was on this, and I still have to get the software updated on my computer when I switched out
The
computers.
fraction bar is control division.
Control
Yeah.
division. Woo-hoo. Everybody see that? Control division? Control is the little blue button on the left about halfway up, and then just the division symbol. Makes you a nice little fraction bar.
But where's the flag?
Bottom left. Bless you. Bottom
On the keyboard.
on the left, it's the bottom left, one up from the bottom left. Well, you knew what I meant. So 200 tagged down to 16.
Mr. Murphy, whenever it gets yours, press that number by the button by the book, it pops up next to the first one, the thing you click on.
Button by the book.
The button by the book, the button left of the book.
This one.
No, the book.
Oh, yeah.
The book.
To the,
It's right above the
above the,
multiplication division.
Oh, okay. I see it. Yeah.
Don't press the book, press the thing next to it.
All right. So let me see here. So control division
Oh,
200
there.
over 16 book.
no, the book,
Like this.
the book gives
No.
you the,
the one
You
there.
can just press. Escape.
Oh, okay. I thought you said the book button. I didn't see the next button. I'm sorry. Yeah. Okay. Cool. Yeah. So to get the fraction bar, nice. As much. It's just. Yeah. It's nice. So you have 200 divided by 16 pi.
wait, is this still like one?
Pi is right here.
Oh.
You have to hit twice.
4, 5. You, no, you push it and then you push. You can't hold it.
No, holding it down pops the menu up, then you can get pi, the imaginary infinity.
Wait, how are you gonna?
Oh, go back.
Oh. Cameron! It's fine.
Yeah, we should be alright.
It's fine.
Oh, I had too much pi.
What? Oh. That's not pressing pi twice. What days? I'm gonna look up what day pi day is. What day of the week? I was like, Madeline.
I was about to.
I'm not that
I
dumb.
never did as a freshman.
March 4th. It's a Monday.
I'm not gonna throw it at you.
It's a Monday, and let's have a pie thing, and I'm gonna say the most pie.
I'm not gonna throw things at people.
Oh,
You will.
Once you get like.
But you,
But what?
you did earlier.
When? Well, I threw it to him, not at him. Hey, Caleb, catch. This is throwing it to him.
This is going.
The last grouping of these problems then really are nothing more than working with some literal equations. I want to let you guys just have some time now, work on them. I'll meander around, help you out, and then we're going to collect the day 1 and day 2 stuff at the same time.
So you're collecting.
I'll collect it. Okay?
No. I don't like ripping these out.
You'll get over it.
Oh, yeah, I guess you did, I guess you did rip these out.